This is a tutorial on how you can create rigid areas of deformation inside of a lattice. So what I have here is a simple squash and stretch lattice rig on this head. And what I want is for this region around the eye to remain rigid, but still move with the squashing and stretching motion. So the first thing that I need to do is create a small surface at the center of the eye. So I'm going to snap a joint to the eye center, and then I will create a NURBS plane and snap it to that same pivot. And then we can delete the joint. And I'm going to make this surface smaller because we don't need it to be that big. And I need it to be linear instead of cubic. So now I'll freeze transforms on it and delete the construction history. And I will name this surface head squash C matrix source. Because what we need to do is we need to get a matrix off of this surface and use it to deform the eye and the region around the eye rigidly. But before we do that, we need to make sure that the surface is getting deformed by the lattice with the rest of the mesh. So I'll go into the relationship editor and add it to the deformer set. So now you can see when I move the lattice around, that surface is moving with it. So let me bring back the head mesh. Now what I need to do is get the matrix off of the surface. To do that, we're going to jump into the node editor. So we have the surface. I'm going to create a point on surface info node and connect the world space attribute from the surface into the input surface of the point on surface info node. Then I'm going to create an aim constraint node so we can turn these vectors from the point on surface info node into an actual matrix. So I'm going to take the normal vector and plug it into the target translate for the aim constraint. So that's going to be used as the aim vector of the matrix. And I'm going to take the tangent v and use that as the world up vector for the aim constraint, which would be the secondary vector for the matrix. So now I'm going to create a locator and connect out the rotation from the aim constraint and the position from the point on surface info node. And we'll see if the orientation is what I want it to be. So it looks like it's not quite what I need it to be. So let me jump into the attribute editor. So it looks like the aim axis needs to be y, so that y is coming off of the normal of the surface. And then the up vector would need to be x, so that, well, let me see. Okay, so setting the up vector to -1 in the z axis gets us the world orientation that we want. So I'm going to name this locator head squash C matrix post matrix, and I'm going to duplicate it and name this one pre-matrix. And the pre-matrix is just going to stay in the original position. And the post-matrix is the one that has the connections going into it. So now what I'm going to do is I'm going to take the head and I'm going to create a cluster deformer on it. Oh, well actually I need to duplicate it first. I'm going to name this mesh head squash C rigid, because this is what's going to get us the rigid deformation, and we will create a cluster deformer on that mesh. So let me jump back into the node editor. So here in the node editor, we're going to make connections into the cluster xforms attribute of the cluster node. And so the first thing we need to do is plug in the pre-matrix, which would be the world matrix of the pre-matrix locator. Then we need to put in a weighted matrix, and the weighted matrix has to be the difference between the matrix from the pre-matrix locator and the matrix from the post-matrix locator. So to get the difference between those two, I'm going to create a multiply matrix node, plug in the world matrix attribute from the post matrix, and multiply it by the world inverse matrix of the pre-matrix node. And I'm going to take that matrix sum, which is actually the product, and plug it into the weighted matrix. The post matrix needs to be the inverse of the pre-matrix. So instead of grabbing the world matrix off of the pre-matrix locator, I'm going to grab the world inverse matrix and plug it into there. So now when I go to move this, you'll notice that even though the difference between these locators has changed, this head that has the cluster node has not deformed at all. And that's because it isn't going to use these... Hold on a second, did something get disconnected here? Yes. So that's what it needs to be. The reason that it hasn't updated is that it won't recognize the cluster xform attributes until we've actually painted on the mesh. So I'll go into paint, cluster 3, and I'm just going to replace it with 0, and then replace it with 1, and you'll see that now the entire mesh has been rigidly deformed up by the cluster. And you can see, well, it might be difficult to see, but the eyes of the rigid mesh and the one deformed by the lattice are aligned. They're both in the same position. But of course the one on the rigid mesh hasn't been stretched or squashed. So now what I need to do is select the rigid mesh and then select the one deformed by the lattice and go to deform blend shape. And you want to make sure that this blend shape is at the end of the chain. So I'm going to name this blend shape rigid eye. Set that to 1. So now when I do this, the entire thing is going to look as though it's being deformed rigidly. But what I can do is I can go into paint, blend shape, and select that target. And I will start by flooding everything to 0 so that it is just deformed by the lattice and it's not getting any influence from that blend shape. And then I'm going to select all the vertices we want to be deformed by the blend shape. So all I've done is I've smoothed out the weight around the eye and fixed it up. And so now you can see that when I squash and stretch with the lattice, the eye moves with the lattice, but that region of the mesh remains rigid within the lattice. So if I come up here, you can see the difference between the right eye, which is getting stretched and squashed into the side, and the left eye, well, the character left eye, which is remaining rigid.